brief this from the beginning of the module because of the fact that I was on cold medicine yesterday. I don't feel the notes were fantastic. Make sure you have your notes out from yesterday. So if there was anything that you missed or you feel I missed in the explanation, it will be covered today. I'm going to shut off the light just because my people say you can see the board.
Oh, no, not that.
This entire book is about transformations. Okay? This is what we're studying. Transformation is when you have an original figure and you do something to change that original figure, whether you are changing its location, if you're flipping it, turning it, whatever. It's a transformation. Eventually we'll study transformations where our figures get bigger and smaller. However, we are going to start with rigid motion transformations. Okay? Meaning that when we create an image, it is going to be the exact same size and the exact same shape as the original figure. Okay? The three rigid motions we're going to study are translations, which the example is the wall, which is a slide. The figure does not turn in any way whatsoever. It is just slid from one position to another. The second rigid transformation is a rotation. I took this image right here, I clone it, and I get a second image, I drag it to the side, and I rotate it 90 degrees, okay? Same as the original, exact same size and shape. The only difference is it's now rotated 90 degrees. It has not changed in any other way. Finally, the third rigid transformation, or the third rigid motion, is a reflection. It's where you take a figure and you flip it over a line. Are there any questions on what a rigid transformation is? Okay, these are the three that we're going to study. Yesterday, we looked at, wrong slide, we looked at this particular lesson, and I found this handy dandy thing that I can screen capture. Here's our original figure. And the question was, how do you get these three figures from the original? Oh, look, I have an extra. This guy has to go. Delete. Okay. How do you get these three figures off of the original figure? To get number one, you can take it. See, this is what I've learned on my smartboard. I can copy paste. Slide it directly into that position. You get the exact same figure that you had over there. So this, of course, is an example of a slide or
translation.
Okay, we're going to use math terms, translation. Go back to your original. Now we have to get number two. If I slide it over, does it look like that?
No.
No. So the slide doesn't work. What if I rotate it? Can I get it to look like that in any way?
No.
Nope. Obviously, we're going to have to flip it down. Okay, and then slide it over, and hey, there's figure two. Questions on what a flip looks like, or a reflection? Okay. Let's put it back. Again, we're back at my original. Now we have to get here. You rotate it in a circle, translate it over, and you get figure number three. This is what we did yesterday. Are there any questions, comments, or concerns on rigid motions and how to move them about? Okay, we're going to move on to lesson 2. I am going to go over some key vocabulary you need for lesson 2. Notes. You need to know what the difference is between a line segment, a ray, and a vector. Because I'm going to use these words like you know them, okay? And there are differences. So you're going to take notes on these vocabulary terms. Line segment, a ray, and a vector. And its markings. So the first word is a line segment. A line segment has 2 endpoints. The line line segment happens in between these endpoints. And the notation is the two endpoints with the straight line across the top. Any questions on a line segment? The next word is array. Array has only a beginning point. After that, array has a direction, and it'll continue on in that direction continuously, infinitely, forever and ever. This is array. It has a beginning point and then continues on in the same direction forever. Its notation is the beginning point, and above it is a line with an arrow. Okay? This is the notation for array. And finally, a vector is a combination of both the line segment and the vector, and the array. A vector has a beginning point and an end point. Okay? Different from the line segment because the line segment has just two endpoints, so either side could be considered the beginning and the end. Okay? A vector has a definite beginning and a definite end because a vector also includes an arrow that tells you the direction in which it's traveling. The vector is going to be the symbol we will use when translating images. Everyone okay with this? All right, so here it is in motion. Here I have an original figure. Here is its image. It is translated along vector AB. Now, if this were my original and this were my image, notice that B is the beginning and A is the end because of the direction of the arrow. It would be written as translated along vector BA. The way that you note it is important. Any questions on how to use vectors as notation for translations? Okay, press pause.